So hello everyone. So our today's lead code question is 3637, that is Trionic Array 1. So in this question what we are given is we are given an integer n nums whose length is n, and we have to find whether this array is trionic or not. So what is a trionic array? So a trionic array is an array in which the first part is strictly increasing, then strictly decreasing, and then again strictly increasing. So see here we have taken from index 0 to index p, it should be strictly increasing. Then from p to q, it should be strictly decreasing, and from q to n minus 1, it should be again strictly increasing. If these three conditions satisfies, then we will be returning true, else we will be returning false, that it is not trionic. So we have to check whether p and q are existing or not, right? So if you'll see an example, so here we are given our array is 1 3 5. So 1 3 5, then 5 to 4 decreasing, 4 to 2 again decreasing, and 2 to 6 again increasing, right? So we can see strictly increasing, then decreasing, then increasing, means it is trionic, right? Next our array is 2 1 3. So 2 to 1 and 1 to 3. So any array of length 3 will always be non-trionic, because we need 0 p q and n minus 1. That means at least we should have 4 elements for an array to be trionic. So it will not be trionic. So any array of length 3 will not be trionic. So in that case we will be returning false. So if you'll see our constraints, our array length can be up to 100, and elements can be from minus 1000 to 1000. Next, let's see the approach. So in the approach, we have to simulate whatever asked in the question, that we have to find that whether our first part is increasing, then decreasing, and then again increasing. But there are some possible cases where, like, how this will be failing. So if we'll see first case, like we don't have any increasing step. So see this array 5 4 3 2. So directly it is decreasing 5 to 4 to 3 to 2, right? Means 5 4 3 2, no increasing step at all, right? So it failed. Or what other can be, like first decreasing then increasing, but we don't have the first increasing step. The other case is like instead of increasing it is a flat line, but in the question we are asked strictly increasing, means two numbers can't be same also. That also makes our this fail. So first is like no first increasing step, right? Then what can be the second case? If the array is fully increasing, then also it will fail, because we need increasing, then decreasing, and then again increasing. This is what we need. But if it is fully increasing, then also it will fail. What is the next thing? Next thing is first increasing, then decreasing, but no final increasing. If that case also, we won't be fulfilling our trionic condition, so that also fails. So see 1 to 3 it is increasing, then 3 to t decreasing, and 2 to 1 again decreasing, but there is no increasing phase again. So it also fails. So if you'll see the fourth condition, so fourth condition is like first increasing, then decreasing, then again increasing. So if you'll think like our condition is satisfied, but the thing is that the array is not fully covered, means still some elements are left. So what can be the cases? Increasing, decreasing, increasing, then decreasing, then again increasing, and suppose again decrease. But we need only these three steps, but this is additional step. So it won't be satisfying our condition. Or what other can case can be? Increasing, then decreasing, then increasing, and then constant stable, like, right? That also is not satisfying our condition. Some other cases are also there. In that case, like there is no decreasing step at all. So see this example, 1 to 3, 1 to 3 increased, then 3 to 3, instead of decreasing it is constant, right? And then 3 to 2 it's decreasing, and 2 to 4 increasing. So if you see increasing then decreasing then increasing, no, it's wrong, because we want it is mentioned in our question that it should be strictly increasing, but here see it is constant. We don't need those cases also. And sixth condition is equal adjacent elements, that is see 2 2. So we won't be uh, we won't don't want any constant line in any part of the what we called that increasing decreasing, or we only want increasing then decreasing and then again increasing, no constant lines at all in at any point, right? So let's see the code. So if size is less than 4 we have to return false, because we need 0 p q and n minus 1, at least 4 elements should be required. So if the length is less than 4, then it won't be possible to make a trionic array, or the array is trionic, right? Then first we'll check the strictly increasing phase. So what we'll do is, we'll if our I plus 1 is less than the array size and nums of I is less than nums of I plus 1, then we keep increasing until this condition is satisfying. Then we will be taking our p is equal to I. And if our p is equal to 0, what does that mean? Means there is no strictly increasing phase, right? In that case we have to return false, because it's must that first phase is increasing then decreasing and then increasing, right? And what this condition is showing, if p is greater than equal to n minus 2, means either our array is strictly increasing fully, or it is strictly increasing up to n minus 2, but no more elements are left to simulate the decreasing and increasing phase. So in that case also we have to return false, right? Suppose these two conditions are not satisfied, then we'll move to this thing. Then what we want, secondly we want strictly decreasing, right? So if our this condition, to check whether the array is not what we call fully covered, and nums of I is greater than nums of I plus 1, right? In that case we will be skipping the elements. Then we put our index in q, and if I, this p and q are equal, means there is no decreasing step, right? In that case we have to return false. So what can be the possible case here? Increasing then constant, this can be the case, right? So this case we won't be considering. What other case can be? So if it is increasing and then fully decreasing, right, then we have to return false also, because there is no element left to simulate increasing. So in that case also we have to return false. Now suppose these two cases are satisfied, then the third case is again strictly increasing. So we again write the case, increase the I pointer, and if our I is not equal to n minus 1, then we have to return false. Means we get increasing, we get decreasing, again we get increasing, but still some elements are left. Means our array is not fully covered, means our array is not fully trionic. So in that case also we have to return false. Or what other case can we? Here this q has already reached to n minus 1, like this case, increasing, decreasing and then constant line. So this was also not considered. So high, and at the end if all the three conditions are satisfied, then we will be returning true. I hope you are able to understand this question, and if you like the video please make sure to share and subscribe. Thank you.